Now dear student, we are going to discuss question number 4.23, and in this question it is given to you a uniform magnetic field of 1.5 Tesla exists in a cylindrical region of radius 10 centimeter. Okay, fine. Its direction parallel to axis along east to west, and a wire carrying current of 7 ampere in north to south direction passes through this region. Okay. What is the magnitude and direction of force on the wire if number A, the wire intersect axis? So actually you can see here in this question it is given we are having a uniform magnetic field that is exists in a cylindrical region. Radius of that cylindrical region is also given to you, and direction of magnetic field it is given that is along the axis along the axis east to west. Clear? Now it is also given we have a wire that is actually going through this cylindrical region and having current 7 ampere and from north to south direction. Fine. So let us try to solve this question. Actually we have three parts of this question. Now we have to provide here answer of each and every part. Clear? So now concentrate on a screen. Now dear student, now we are going to solve this question. First of all, if I am saying to you, let's suppose if I draw here a diagram, let's suppose I am assuming this is a cylindrical region. Listen very carefully. Clear? Cylindrical region. Let's suppose I am saying this is direction north one, this is south direction. Clear? And I can say, let's suppose this direction is east and this one we have west direction. Clear? Actually what will happen here, this is west direction, this is east direction, and I am saying this is north and south. Actually this north south direction is what? You can see like this. This is east direction, this one is west direction. I am saying this one is north direction and this is south direction. Clear to you? So if I am showing it like this, it means you have to assume here actually we have a wire, this is not like this, this wire is like this. Clear? So I can say this is east, this is west, this one is north and this one is south. Clear? So now we are going to solve first part number A. Now concentrate here. In this question it is given to you a uniform magnetic field exists in a cylindrical region from east to west. So I can say here direction of magnetic field it is given to you in this direction, and magnitude of this magnetic field it is given 1.5 Tesla. Fine. It is also given here it is having radius. So I can say this cylindrical region having radius 10 centimeter. Fine. Its direction parallel to, okay, direction is clear to a wire carrying a current of 7 ampere in the north to south direction. So now we can say, let's suppose here we have a wire and that is wire that is going like this. Actually this wire is also passing through the, we can say axis, we can say actually it intersect axis or not, it will we will decide from this particular parts. Clear? So in this question it is given to you simply a wire carrying a current 7 ampere from north to south direction. So let's suppose I am saying this is a wire. Clear? And this wire is going from north to south direction and current is given to you, that is 7 ampere. Clear? Now we have to find what is magnitude and direction of a force number A when the wire intersect axis. So let's suppose I am saying you can see you can observe like this. Let's suppose this is cylindrical region. Clear? In this cylindrical region we have a wire like this. Clear? And current is going from north to south direction, and it is also passes through, it is also intersecting axis. It means I can say this wire is passing through, if I am observing from this side I can see circle. So it is passing through the center of circle. Clear? So now we can say our objective here is to find first magnitude. So I can say F, this is given by BIL, that is sine of theta. Clear? You can also write like this, this is I L cross B. Clear? We can say I, this is L cross B. Clear? Now value of I is given to you in this question, that is 7 ampere. Clear? So I can say 7, or you can say, you can place here value 7 multiply. What is value of B? Value of B it is given 1.5. Now important part, what is L? Clear? L is, we can say, length of a wire that is inside this cylindrical region. Clear? Now you can say actually this wire is intersecting axis. It means we will take length along the diameter. Clear? So now we can say we will take this length. Let's suppose this length is L. Clear? And this length we can say that L equal to twice R. Clear? So this 2 multiply what is value of R? R is given to you, that is 10 centimeter. So 10 multiply 10 to the power minus 2. Clear? Now you can say what is theta? Theta is angle between what? Because this is L cross B, so we can say this L and this B both are perpendicular to each other. So I can say this is sine of 90. Clear? So from here you can write like this. This is equal to 20 into 10 to the power minus 2. So 2 into 10 to the power minus 1. Clear? Multiply, I can say 15 by 10 multiply 7. Clear? So from here you can say this is 30, or I can say that is 10 divide by 100, and this one is equal to 2.1 Newton. Clear? So we are getting here force acting on this wire, that is equal to 2.1 Newton. Why force is acting? Because whenever we place a current carrying conductor inside a magnetic field, it always feel a force. Clear? So this is all about part number A. Clear to you? Now we are going to discuss part number B. If this wire is turned from north south to northwest or northeast direction. Clear? Now let us try to understand what will happen in second situation. Clear? Let's suppose if I draw again a new diagram, it will be better for us. So yes. Now you can say, let's suppose this is same cylindrical region that we are assuming. Clear? I can say this is direction, that is direction north and south. This is north one and south one. You can see now this direction is perpendicular to this screen. Clear? Direction of B, that is given to you from east to west. Clear? Now it is given. Now we are changing up little bit. What is the change? Now we are placing this wire north south or northwest direction. It means, let's suppose I am placing like this. Here we have northeast direction. I am placing in northeast direction. Clear? Whenever I am saying northeast direction, actually what parameter will change? Is current changes? No. Current is already given to you. Current is flowing in this direction, that is 7 ampere. Clear? But we can say length of that wire inside this cylindrical region, that changes. Clear? So we can write like this. F equal to this is actually part number B. Clear? So F equal to, I can say this is BIL sine of theta. Clear? Value of B. Value of B we can see from this slide. Value of B we have, that is 1.5 Tesla. R we have 10 centimeter. So 1.5 Tesla, 7 ampere current. Length we can say, actually let's suppose I am saying this length is what, L dash. Clear? From here you can say, if I draw here perpendicular. Clear? If I draw here a perpendicular. Clear? I can say this angle we know, that is 45. Clear? This angle is 45. I can say this one is 45. This one is also 45. Clear? We know this value we have, that is L. Clear? So can we find here L equal to, this is L dash cos of 45. Clear? I can say this angle is 45. So L equal to L dash cos of 45. So from here I can write L dash equal to L upon cos of 45. Clear? Value of L. Value of L is what? We can say this is equal to twice R. Clear? Twice R divided by, I can say that is 1 by root 2. So this is equal to 2 root 2 and multiplied with R. Clear? 2 root 2 multiplied with R. So 2 under root 2, what is value of small r? Clear? Small r value, this is given to you. Yes, that is 10 centimeter. Clear? So I can say we can convert into meter. So this is equal to 10 to the power minus 1. So now we can say this is 1 by 5 multiply, I can say 1.414. Clear? Yes or no? We can write like this. Clear? Or you can say correct. This one is correct. Or you can also write like this. This is just the value of L dash. Clear? So we can place this value here better. Clear? So now I can place this value here. Value of L, this is equal to 2 under root 2. Actually here we will take not L, this is L dash. Clear? So this is L dash and I can say sin theta. So 2 root 2. Clear? And I can say this is multiply 10 to the power minus 1 and I can say this is sine of 45. Clear? Sine of 45. So from here we can write force acting on a current carrying wire. This one is given by 1.5 multiply 7 multiply 2 root 2 multiply 1 by 10 multiply 1 by root 2. I can say this one and this one cancelled out. Clear? or we can say this one we have 10. So from here we can say this is 14. So 14 multiply 15 divided by, I can say this is 100. Clear? So if you multiply it, you can say F is given by 210 divided by 100, and we are getting magnitude, this is 2.1 Newton. Clear? Actually, can you find here direction? Yes. Now we can say, let's suppose these fingers are representing direction of magnetic field. Clear? Let's suppose my thumb, this indicating direction of current. So definitely I can say direction of this palm is representing force acting on that conductor. It means definitely I can say here, if I show here direction of force acting, that is vertically downward direction. Clear? So now we can say this is magnitude. If I write here direction, that is vertically downward. Vertically downward. Clear to everyone? Yes. Now let us try to understand part number C. Clear? Now I am showing to you part number C. Part number C. Let's try to understand what is part number C. The wire in north-south direction is lowered from the axis by a distance of 6 cm. Clear? Now listen carefully. Actually, this part will be little bit confusing for a student, but actually this is very simple part. Let us try to understand. Let's suppose we have this cylindrical region. Let's suppose this is cylindrical region. Clear? In this cylindrical region, you know, I can say this is center. Clear? And you say this is north and south direction. This is clear to us. But this situation will be there where in part number A and B it is given this wire that is along north-south direction, it is actually passing through, it is actually intersecting axis. But now it is given here that we are lowering this wire by 6 cm. It means, now you can say if you are placing north-south direction wire, I can say this will be like this. Clear? But if you are lowering by 6 cm, it means I can say you can lower it like this. Clear? So it means if you observe from this side, how can you see this diagram? Listen carefully. Let's suppose, because if you are observing from right side, you can see this is a circular part. Clear? I can say this one is center. Clear? I can say this one is center, and actually initially you can see this is north direction, this is south direction, and wire in this direction. Now I am lowering this wire by 6 cm. It means I can say actual this is the direction of it is actual position of wire. Clear? So I can say, let's suppose this is north, this is south. I can say current is flowing in this direction. You know very well that is 7 ampere. Clear? But from here you can say this distance is what? This distance is given to you 6 cm. I am assuming from here this distance is x. Definitely this one will be also x. Clear? Now if I join here these two lines, I can say definitely this is equal to radius. So 10 cm, 10 cm. Can we calculate here value of x? Yes. So how can we calculate? We can apply Pythagoras theorem. So I can say this is given by 10 square. This is equal to x square plus 6 square. Clear? So from here I can say x square, this is given by 10 square minus 6 square. Clear? We can also write like this. This is 100 minus 36, 64, or we can say this is 8 square. Clear? So value of x we can say 8 cm. Now you can say, sir, why we are writing this value? So listen carefully. Now we will find here total length of this wire that is present inside this cylindrical region. Clear? So I can say the part of that wire that is present in this cylindrical region is this one. Yes or no? Clear? So I can say from here value of L that is written by 2x. Clear? That is 2x, and I can say this is equal to 16 cm. Clear? Definitely current is flowing in this direction, no problem. Clear? And we can say magnetic field is, let's suppose this is north, so you can say this one east, this one is west. So I can say in this diagram magnetic field is perpendicular inward like this. Clear? So directly we can say angle between this wire, or we can say this current, or we can say this L and this magnetic field, that is 90 degree. So I can say force acting, that is given by BIL sine of theta. Let's suppose I am taking this L double dash. Clear? So from here value of B we have 1.5 Tesla. This is 7. What is value of L double dash? 16 centimeters. So 16 into 10 to the power minus 2, and I can say perpendicular. So we can say this is equal to sine 90. Clear? So we can say this is equal to 16. So we can say that is 24 multiply 7 into 10 to the power minus 2. Clear? So 27 multiply, I can say here we have 168. Clear? And it is divided by 100. So from where we are getting answer 1.68 Newton. Clear? And what about direction of a force that is acting? So I can say these fingers are representing direction of magnetic field. This one is representing direction of current. So I can say again we have vertically downward direction. Clear? Vertically downward direction. Clear to everyone? Yes or no? So this is all about this question.